Hey, in this video, I'm going to give you two examples for graphing sine function, one with the radian measurement of angles and one with the degree measurement of angles. So I have an example in front of me here. I have a sine function equation. Clearly, this is not the parent function. Just to review parent function, sine theta or sine x. Let's use x. It doesn't matter x. But this is the parent sine function. If you recall, parent sine function passes through the origin, halfway through goes above, all the way to 1, and then fluctuates between 1 and -1, and the other half comes down and then stops at this one cycle. Now this is exactly one cycle, like I said. Also, my second loop was a little bigger than the first loop, so that's bothering me, but here it is. That's one cycle. Right, and the period is 2 pi. What was period again? The time it takes to complete one cycle, that's the period. So in this case, 2 pi for the parent function. Then comes in the amplitude, goes up to 1, -1. Range fluctuates between 1 and -1. Domain is all real numbers. Halfway through this would be pi. So keep that basic shape in mind. If there was to have a negative, if this was to have a negative, then obviously the graph is going to flip. But again, we're still stuck to the origin, go down first, then we'll go up. And that's the basic parent function. This one is the one where it will be reflective, would have a negative in the front. So keep the basic shape in mind. All right, so when I look at this, let me first identify what's going on. I see a negative in the very front. So if I were to say, is there reflection, then I would say yes. The A value here is going to be the very first number. So the amplitude of this function is 4. Then comes in identify B. B is the number that's sandwiched between sine and x, so it would be 2 in this case. But watch out here, something very important. I'm actually going to erase this. And have you noticed how the B value, like this is A, that's B, and this is supposed to be C, which is the horizontal phase shift, and the very last number at the very end represents the vertical shift, so up and down shift. But if you notice how B is distributed, so the first thing I'm going to do is undistribute B to get the exact value of C. Negative stays, 4 stays, sine is sine. So I'm going to undistribute that 2 there, which leaves me with x as the first term. But now the second term is not pi. The second term is going to be pi over 2. What that means is I'm making sure that when I redistribute the 2, I get 2x and then minus pi again. And then plus 3 here. And now I'm going to identify my ABCD. So number 1, is there a reflection? Reflection? Yes, there is, because it's negative. A value is 4. B is 2. C, which is the phase shift, which is the number inside the parentheses here, is pi over 2. Because it's negative, I'm just going to tell myself that, hey, we want to make sure we're going to switch to the left. And then D is positive 3, which means up 3. Also, when you're given an equation, we can extract ABCD from it. We do not know period, but I can simply use the formula period is 2 pi over B to get the period for this, which is going to be 2 pi over 2, which is going to be pi. If you recall, this is also the frequency, and the minute I looked at the B value 2, I said to myself in my mind that this wave is going to be much faster than the parent wave. It's going to be twice as fast, which means if the period of the parent function is 2 pi, this is going to complete one cycle in just pi. And the period does turn out to be pi. In other words, this wave is a faster wave. By the time parent completes one cycle, this wave is going to complete in pi, it's going to complete one cycle. And then by the time you get 2 pi, it's going to complete 2 cycles. We're only looking at graphing one cycle as of now. So I got all my ABCD values. I basically am going to start with the center line or the midline. The midline is going to be where the vertical shift is going to be. So midline has shifted up to 3 to get an idea of how high and how low my wave is going to go. Amplitude is going to tell me that. Since the midline is at 3 and amplitude is 4, 3 plus 4 gets me as high as 7, and 3 minus 4 gets me as low as -1. So this wave is going to fluctuate between -1 and 7, and the range is going to be between -1 and 7. Then comes in the start point of the wave. This wave has shifted to the, wait a second, this was supposed to be right. Oops. Oopsie daisies. Minus means right, and then plus means left. So this has scooted to the right pi over 2. So starting point on the midline is going to be at pi over 2. Then comes in, I need to figure out the end point, but let me also go ahead and get my 4/4 going. I need to have my start point to get my 4/4. So let's say here's the first quarter, second, third, and fourth. Now you can see my graph is split between quarter 1, quadrant 2, quadrant 3, and quadrant 4, which are 4/4 also. So I got that going. I got the starting point. Now comes in, what will be the end point of the cycle? Well, the end point, because the start point has scooted, end point is also going to scoot, but the end point is simply the start point plus the length of the period. Wherever it starts, if you add the length of one cycle to it, that's exactly where one cycle ends. In this case, start point is pi over 2. I'm going to add period to it, which is pi also in this case. But then I can't add unless I make it the same denominator, and that comes in 3 pi over 2. So the end point is 3 pi over 2, this one. Then comes in, what about the midpoint? These are critical points. These 3 would be the x-intercepts. What's right in the middle of 1 pi over 2 and 3 pi over 2? Isn't it going to be 2 pi over 2? But then that's simply pi. So what's the point of writing 2 pi over 2? Simply pi. Then comes in 1/4 and 3/4 of that. So halfway between pi over 2 and pi would be, because that's half pi and that's full pi. Between half and full is 3/4. So that's that. And then between 1 pi, so I have 1 pi here, and then 3/2 of pi is 1.5 pi. What's right in the middle of that? Isn't it 1.25 pi? Now 1.25 is basically 1 1/4, which is 5/4. So this point is 5/4 of a pi. So I got all 4 critical points, and I should be able to put this shape together. Like I basically am looking at putting this shape together, but wait a second, this is reflected, right? So I'm going to make sure I reflect my graph. And from the starting point, in the first quarter, it reaches its minimum value, and back to x-intercept. In the third quarter, reaches its maximum value, and then back to this. And I have graphed one cycle of the equation that was provided to me. So be very careful. This was my first example. In this one, B was not pulled out. So the first step I did was pull out B or undistribute B. That changed the number that sits here, and the number that sits here is the C value. If you do not undistribute it, you might end up using pi as a C value, and which will throw our entire graph off. So be careful there. Okay, let's use a degree example. Oh, you know what I did not do here? I did not put in where x and y axes are. Since the starting point is pi over 2, y axis is going to be somewhere to the left. So now I go and come here and define my y axis. And then x axis clearly is going to be here between -1 and 3, right? That's where 0 belongs, and here's the origin. So now the wave is put in perspective. All right, let's look at the second example, degree one. So this is 180 degrees. Now notice here how B is again distributed in. So you have to pull it out first, 4, and then see what's left over. Obviously x from here, but then this is not 180 anymore. It's 180 divided by 4. So that 4 and 4 cancel when you distribute it. So that would be 180 divided by 4. 180 divided by 2 is 90. 90 divided by 2 is 45. So 45. Oops. 45 degrees. And then -2, which means that's the drop. See, on the side, if I go ahead and see, hey, do we have any reflection? Not on this one. What's our A value? Amplitude is 3. B is 4. If B is 4, then P is 2 pi over B, and hence pi over 2. So that's the frequency. This wave is 4 times faster than the parent, and hence it completes one cycle in 1/4 of the cycle of the parent, 2 pi. It's a very fast wave, pretty skinny. Then comes in C, which is 45 degrees, and then D is -2, which means down 2. And this is where our midline is at, so I'm going to draw a midline. I'm going to call that -2, that's where it is. Amplitude is 3, so plus 3 to that would be +1. So I'm like, where's the max and where's the minimum? Okay, so plus 3 to that. This makes it 1 here, and then -3, so -2 minus 3 is -5. And the wave fluctuates between this. Got that going. Then the starting point. So it's 45 degrees again to the right. Maybe I should have shown a to the left example. Yeah, that's fine. Let me do it. Let me just now change the question. So what? Plus. So you can see to the left there. So 45 degrees to the left, which means I am at -45 degrees, which means y-axis is to the right of this, right? Also, what about the end point? So end point is start point plus period. Start point is -45 degrees. And then period, I have listed period as pi. So since we are in degrees, I've got to use 180 instead of pi. So that's 90 degrees. So period is 90 degrees. Obviously, I can't add radians and degrees. So plus 90 degree. Okay, 180. I'm just making sure that I did this right. B is 4. The regular period is 360, half of that. Yeah, that works. So this is 45 degrees, which means wherever I end the cycle, that's 45 degrees also. 45 plus 45, total 90. And also because this is positive 45 and the start point was -45, so I better make them even, right? I can't have 45 too far from y-axis because it's... I just want to erase the little tick sign. There we go. I'm going to make that tick sign somewhere here so that it's justified. -45 to the left and -45 to the right. So smack in the middle of this would be the origin, right? Halfway, -45, +45. And then a quarter would be -22.5 degrees. And then this one would be +22.5 degrees. There's no room there, but I've split it up in 4 parts. So here's the start. First quarter right there. Second quarter is on x-axis, y-axis itself. And third quarter is from the y-axis to this dotted line. And fourth quarter is from there to there. So quarter 1, quarter 2, quarter 3, and quarter 4. It's a pretty fast wave, and hence it's so shrunk up. It's skinny, basically, which is horizontal shrink. And there's no reflection, so I got that. -2 has been taken care of. Midline has been taken care of. And I think I've taken care of everything. It's time to put it together. And there's no reflection, so I'm going to start at the start point, -45 degrees. First quarter reaches maximum. Halfway through, minimum, and back up. There we go. And I have graphed this given equation, which was listed in degrees. So remember here, formula was 2 pi over 4, but I had to change it to 360 over 4, and I did that at the very end so I could find the end point. It was important because that's how I knew where it ended. Hopefully that was helpful. See you in the next video.